So the next project that we are working on is smart pet feeder. So we will be using WalkY again for this project. Just go to Google, type WalkY, log in with your credentials, and then start from Arduino and then click here on Arduino UNO. So here the concept will be like, I'll be writing the concept here for you, but this is a coding part, okay? So just to display you. So the concept is basically something like, it will be automatically feeding a pet at a scheduled time, like detecting if the pet is near the feeder before dispensing, providing the feedback via LCD and LED, optional buzzer alert if food container is empty, and it will help you to understand automation, sensors, actuators, and IoT logic. Now let's move forward with the components part. So the components that we will be using, the first one is Arduino UNO, that will be a micro controller. The second component that we will be using a servo motor, okay? So this is like for dispensing the food. The third component that we will be using is IR sensor, or we can use ultrasonic sensor. So HCSRO4 ultrasonic distance sensor we will be using. It will detect the pet presence, okay? And then we will be using a push button. So make sure this is a simulation only, okay? So push button, manual feed option, and then we will be using an LED that will be used for indicating feeding in process, and then with LED we will also be using here LCD. Why? Because we need it to display status like feeding now, right? Pet not detected likewise. And buzzer is optional here, so I will be using here buzzer as well. That will go for indicating, alerting if food runs out. And then we will be using the resistor, because we are using LCD, and with LED, sorry, we will be using resistors. It will help you, to control the current. Now let's move forward with the wiring part. So let's make the connections here. So the project concept is the smart pet feeder IoT project that will automate feeding for pets. So it will detect when the pet is nearby using a sensor. It will dispense food using a servo motor. It will allow manual feeding using a push button, and it will provide visual feedback with an LED showing the status messages on LCD, and optional buzzer alert if the pet is not detected or food runs out. So here you will come to know about sensor actuator integration, automation logic, feedback mechanisms, and basic IoT concepts. So sensors detect the environment, microcontroller decides, actuators act based on the decision, and buzzer provide the feedback. So let's make the connection. So first we will be making the connections for servo motor. So servo motor has ground, it has V plus, and then it has PWM. So let's make the connections. So ground will be connected to ground. I'll just place this LED a little bit far, and then we will be making the connection for V positive, that is the red wire. So this is Arduino 5 volt, like it will be connected to Arduino 5 volt or external 5 volt for larger servos. So first we will try with the Arduino 5 volt. And then we are left with PWM, so that is basically a signal. So this is an orange, yellow, or white, wire. So this is will be connected to Arduino PWM pin, that is pin number 9. So here we are done with the connections for servo motor. So PWM pin, it controls the servo anger, and servo ground, it must share common ground, with Arduino. And using the external power for high torque servos to avoid Arduino resets. But right now we are using only the here 5 volt. If something happens, then we will try with the external one, okay? Now let's move forward with the next part. by making the connections for IR ultrasonic sensor. The connections, so VCC here will be connected to power supply, that is basically 5 volt. So, and then ground here we will be connecting to ground, and then the TRIG, that's a trigger pulse, that's the output from Arduino, so it will be connected to digital pin number 2. I will be telling you this connections again. So eco pulse input to Arduino, it will be connected to digital pin 4. So how it works, like Arduino sends a short high pulse 10 microseconds to trigger the sensor. Eco pin, that sensor sends a pulse back. Length of high pulse is proportional to distance of object, that's PET here. So chord logic we will do like measuring pulse duration, calculating distance. If distance is less than threshold, PET is closed, feed likewise. Now let's make the connections for LED, for buzzer, for button and for LCD. So first let's go for push button. So push button, the first part will be connected to pin number 3 and the other part will be connected to ground. Now let's go for LED, the positive part with the help of a resistor that will be connected to pin number 5, digital pin number 5, and the negative part with the help of resistor to ground. Buzzer is optional, so we can connect the positive part to pin number 7 and the negative part to ground. And then we have LCD. So LCD connections, ground to ground, VCC to 5 volt, and then STA to A4, and then SCL to A5. So likewise we are done with the connections for our project. So the step number 1 should be like system wait for PET detection, like ultrasonic distance less than threshold or manual feed button pressed. LCD will show status waiting, LED off, servo idle, buzzer off, and then detecting the PET or manual feed, reading the distance from ultrasonic sensor, reading manual feed button. So decision distance less than threshold or manual button pressed. So likewise it will work. So first let's move forward with the coding part. And let's try to execute it. So it might ask you to install liquid crystal library, so you just need to click on that and then execute it once again. So output will go in such a way that waiting, LED is off, status here is smart PET feeder waiting. So servo is idle and buzzer is also off. So if the PET detected, let's say distance here is this much, and let's reduce the distance here. So it is saying feeding now, right? LED here is on, feeding now, and it rotates 90-degree back. Okay, so buzzer is off, right? So for manual feed, so PET detected here means feeding now, that is for greater than 20 centimeter. Now let's try for the manual feed. So status here is waiting. So smart PET feeder feeding now, you can see LED on, buzzer is off, right? So if it is manual feed but no PET, so it will be LED will be off, LCD will show feeding now, it will rotate 90-degree back and the buzzer might beep at that particular point. So the buzzer is optional and serves as an alert for situations where feeding is attempted but the pet is not detected, near the feeder. So it acts as a warning sound to the owner or just as a feedback for the system, right? So here we have condition in the code like if manual feed is equals to digital read button pin tone, likewise here we have the condition if tone buzzer pin 1000. So manual feed is equals to high, the manual feed button is pressed, so distance is greater than equals to free threshold, so the pet is not within the feeding range, for example farther than 20 centimeters. So both must conditions must be true. So if the pet near the feeder button is pressed, buzzer will off. Pet not near the feeder button is pressed, it will off beep, zero point 0.2 or zero point 0.5 seconds. Okay, so let's try to make some changes in the code so that it should beep, or we can try with the existing ones. Yeah, so as it says buzzer is on, it will go for if it is not detected, as I told you, it will prevent the feeding without pet present, food waste, and it will help the owner to know that the pet is not ready for feeding. It works, as a feedback mechanism alongside LCD and LED. So this is how it moves with this stuff relating to this interesting part of pet feeding detection. So now let's move forward with the understanding the coding part. So here what we have done is we have included wire.h. These are the header files, C++ header files. We did the coding in C++ here. So wire.h for I2C communication with LCD, liquid crystal I2C.h to control 16 into 2 LCD easily, and servo.h to control servo motor angle. Then we have created the objects here, feed servo. It controls the food dispenser servo. LCD controls 16 into 2 LCD with I2C address 0 by 27. Then we are defining the pins here. It assigns the Arduino pins to each component for clarity. Long duration, long distance, int feed threshold is equals to 20. So long int, these are data types, and duration is the time the ultrasonic pulse takes to return, and distance of pet from feeder, feed threshold, minimum distance to trigger feeding. Then we have a setup function here, attaching the servo to pin number 9, setting up pin modes, input for sensor button, output for LED and buzzer, and then initializing LCD like turning on backlight and displaying initial message. Then we have loop function, digital write, trig pin low, so it sends short pulse on trig like triggering the ultrasonic wave, reading echo pulse duration, time for wave to return, converting to distance in centimeter using formula. Then we have int manual feed is equals to digital read button pin, so it reads if the manual feed button is pressed high or not, that means low. Then checking here the feeding condition with the help of if condition, so fed if pet is nearby or manual feed pressed. So feeding process, it will go like LCD will show feeding now, right, and LED on, servo rotates 90-degree, dispense food returns to 0-degree, LED off, LCD back to waiting, and buzzer off in case it was on. Then again we have an if condition here, if manual feed is equals to high and distance is greater than equals to feed threshold, so it activate buzzer only if manual feed button is pressed, pet not detected, distance greater than equals to threshold, so beeps 0.5 second, tone generates sound, no tone stops it. So this prevent accidental feeding when the pet is not near the feeder. Small delay 500, like waiting 0.5 seconds before next loop and avoiding multiple triggers too quickly. Let's watch out the output once again. LED off, waiting, status is waiting, servo is idle, and buzzer is also off. So detecting the pet, feeding now, LED on, feeding now LCD and rotates 90-degree back off. Manual feed, feeding now, pet feeder, feeding now, status waiting, feeding. This is manual feed, off and on it says manual, feeding now and then waiting likewise, and buzzer is off. Manual feed but no pet, so we need to increase the distance, right, because there is no pet, so buzzer will beep. This is manual feed, right? LED is off. So basically here it is like rotates 90-degree back and beep 0.5 second. Sorry, LED is on again because it is giving you a kind of a warning message that there is no pet but food is getting wasted, food feeding now. So servo only rotates when feeding is triggered, LED indicates feeding in process, LCD shows status, and buzzer alerts manual feed without pet. So this was the interesting form of I would say the project that we did, a new project, a smart pet feeder with an ultrasonic addition. So you can save it by clicking here on save, and then you can share it with like on your LinkedIn profile, on with anyone you want to share on. So, and that's it for our smart feeder project. We have learned how to use an ultrasonic sensor, servo motor, LED, LCD, and buzzer to make feeding our pets easier and smarter. If you enjoyed this video and want more IoT and robotics project for beginners, make sure to hit the like button, subscribe, and turn on the notification bell so you never miss a project. Comment below code if you want the full code for this, and let us know which IoT project you would like me to make next, or if you have any questions about this feeder. Thanks for watching and happy tinkering, happy walk with your Arduino projects.